Thanks, Taylor. Okay, good afternoon, everyone. I'm Riaz Israel, and welcome to this final stretch of sessions here on Pivot. We are T-3 before beer and counting. Before I introduce the panel, just a quick poll of the audience here. Any drillers or geologists in here today? Okay. I've got a really bad joke about or a quote for geothermals. If you're bit run number 43 and you're having a bad day, may the quartz be with you. Anyway, we can make some drilling, some pivot swag with that, Jamie. All right. Okay, so drillers have a long history. We have a DNA of bringing technology to unlock the most difficult challenges to bring energy to the world. Think of deep water drilling, what we can do in 6,000, 7,000 foot of water. Think of the shale revolution. We've even packaged nuclear magnetic resonance into 6-inch collars and can get formation information in real time. So, technology challenges are not something we shy away from. So now we've got another challenge that we're being asked to deliver on, and that is how we deliver safe and competitive geothermal wells to a world hungry for all forms of energy. So our panel today features 3 speakers who, as Taylor mentioned, are all highly experienced oil field veterans, but who've now pivoted and are working on technology specifically aimed at overcoming some of the key challenges associated with geothermal drilling. Ultra high temperature, low ROP, and bringing heat back to surface. Like I said, they've all had fantastic careers in oil and gas and are now focused on the geothermal challenge. So please give a warm welcome to our panel here. Igor, Kocis, Geothermal Anywhere. John Clegg, Hephae Energy. And Silviu Livescu, Bedrock Energy. No warm welcome, please. Okay, so great to have you all on this panel. Let's jump straight into our conversation here. So my first question is about you. Tell us a little bit about your background, and apart from wanting to be the first geothermal billionaire, what was the spark that convinced you to pivot into technology focused on geothermal? Igor, want to go first?
We started more than 10 years ago to look for geothermal, why it is so expensive, what is the biggest challenge, and we came across a few technologies. We tried to develop and test things that can happen, and then we focused fully on drilling costs, because what we analyzed is that if we are able to make breakthrough in cost and ability to go much deeper in the geothermal project for lower price, then you have a game changer as a tool for the energy companies to make it happen. So with my background, that is technology, basically, we moved through different mechanical and thermomechanical solutions that can drill through the rock, specifically in high pressure, high temperature environments. And it took us several years to move to the stage that we were able to demonstrate the working demonstrator and prototype. And what was most important, that and maybe a little bit funny, that first 10 years we had to really focus on technology and drilling, not talking about geothermal so much, because it was before it was cool. And now last 3-4 years it changed significantly. So specifically our focus now in the company is primarily to move for the deep drilling, when we can bring the geothermal projects below 3-4 kilometers till 6-8 step by step for the reasonable price, and that's the target.
Okay, thanks, Igor. John, want to tell us a little bit about you and what got you excited about geothermal and what you're doing?
Sure, yeah, I've been in the drilling industry since the mid-80s, and 2020 was a kind of, if you pardon the expression, a pivotal year for, well, a strange year for all of us, right?
Yes.
I had a great role going into 2020, which involved meeting people all the time and speaking at events all the time, and kind of in the space of a few days, that role disappeared. And so I decided to step back from the role. I actually thought I was going to retire, more fool me, right? I took some time out, wrote a couple of books, I did some consulting, And with my co-founder in Hephae, Steve Craze, we were starting to think about what are we going to do next? And a couple of people said, you should look at geothermal. And I was one of Jamie's skeptics, right? I was like, geothermal, really? It's just a niche, right? Or maybe it's a niche, depending on where you come from. It's tiny. And, how can that be of interest? But we looked. And we discovered some of what we're now calling unconventional geothermal techniques, EGS and AGS. And we realized that a lot of those would require directional or horizontal drilling, which is stuff that between us we were quite good at, we knew a lot about. And then we realized that actually, unlike drilling for oil and gas, where you're drilling for a particular play in a particular location, it's not quite the same with unconventional geothermal, because wherever you drill your horizontal well, if you go a bit deeper, it's going to get a bit hotter and it's going to get higher quality and exponentially so. The deeper you go, the hotter is better, the more power you get. And so we realized that we had an opportunity to develop something new, which is high temperature drilling equipment, and also the possibility of this kind of infinite technology roadmap where you could just keep getting deeper and deeper as the years go by. But the challenge is, how do you do it? Because the conventional wisdom is that you can't do much above 175 or maybe 200 Celsius. There's a guy called William Gibson, a science fiction writer, and he's quoted as saying that the future is already here, it's just unevenly distributed. And what that means is if you look outside of your industry, you sometimes find things that you didn't think were there. And in our case, if you go look at industries like space, aerospace, and particularly space, you find that there is technology available. Their view of high temperature is very different to our view of high temperature, which is a good thing. So all we have to do is steal their stuff and figure out how to combine it with our stuff. And we can actually make a business which is going to take us to be able to accurately drill wells way above the temperatures that we believe are possible, having been conditioned by our lives in the oil and gas business. So that was kind of our inspiration.
Thanks, John. Thanks for sharing that story. Silviu, you want to share your story about with us, your bit of background and
sure,
why you pivoted into geothermal?
Yeah, can you hear me well? Yes, you can. All right, so I'm Silviu Livescu. I'm another one coming from oil and gas, of course. I was with ExxonMobil upstream research company in Houston, and then for 10 years I was the chief scientist for the pressure pumping product line at Baker Hughes, based in Calgary. And since 2021, I have been teaching the first graduate engineering class at the University of Texas in Austin. And so how I got into geothermal is more about who brought me to geothermal. And so Jamie convinced me much faster than you, John. In 2020, the first pivot, I just watched it. I was in Calgary, and then I started to realize this is going to be big, right? And so I started to talk with Jamie since then, and so here I am on this panel. David Reed this morning was joking about you are on the old guys panel. Well, actually, I'm here to tell you that probably still the best of my career is in front of me. I'm into geothermal now 100%. And so just like everybody else, in 2020, I started to look into EGS, AGS. I'm still looking into those. But right now, actually, I realize that heating and cooling is the lowest hanging fruit with technology that is available today, with all the knowledge we have from oil and gas. And the market is massive. So here I am, representing Bedrock Energy and telling you a great story about how heating and cooling can decarbonize any building in the world. Thank you.
Thanks, Silviu. We'll stick with you. So you started to tell us a little bit about Bedrock. Can you tell us a little bit more about Bedrock and your technology? What do you think that unlocks? And just maybe where are you on that journey?
Right. So I can start by saying that last year, actually, Igor, my co-founder, won the best startup competition. So thank you for that. But jokes apart, if you look at the heating and cooling industry using geothermal, it's decades old. Boise actually has the first system in North America, 1920 or so. So the industry is there. But if you look closer, the biggest challenge they have is very small, very fragmented, and pretty much no innovation in the last, I would say, at least 30 years. And so that many startups actually jumping into the space, rightfully so, and I'm actually applauding all of them. Probably you heard about Dandelion, you heard about Celsius, so kudos to all of them. The market is massive, and we need everybody to to do their part. What we are bringing to the table is that we are a fully integrated technology company, and so we are developing our drilling technology ourselves. We are actually drilling. And we are doing project management and servicing. So you can think about my previous experience in Baker Hughes. We are pretty much a similar kind of model for geothermal heating and cooling. Thank you.
Thanks, Silviu. John, you want to tell us about what you think Hephae's technology unlocks, and where are you guys on that journey?
Sure, yeah. I mean, our technology journey started earlier this year. Steve and I founded the company in January 2021, and we were able to get funding and start activities in March of this year. And so one of the biggest challenges for any company like ours is actually getting the funding to get going. I kind of oversimplified it when I said we're just steal from other industries and package it with our own stuff. But what we did realize is that although we've all got experience in taking existing oil and gas MWD, LWD tools to 200 Celsius and even slightly beyond, to get to the temperatures we're looking at, which is initially 200 to 225, at least to 300, possibly even beyond. And that's circulating temperature, by the way. That's important. I'll come back to that in a moment. We need to do something a little bit different, and we need to package the tools very differently. And I wish I could tell you how we're doing it today, but I can't because we're still in the process of protecting IP. So right now we're filing patents. Every time we think we've got to the bottom of our list, we invent something else, which is, I guess it's a nice problem to have, but it's also, it keeps us busy. We're at the point where we've designed and built our first boards. We're receiving them this month. We've got ovens. We'll start testing stuff this month. And we intend to be in a position where we'll have a prototype tool, MWD tool, by the end of next year. The temperature we're looking at is, we talk in terms of circulating temperature, and that's different from reservoir temperature. So we hear people talking about unlocking 400 Celsius reservoirs. That doesn't necessarily require 400 Celsius drilling tools. So the temperatures I talk about will unlock reservoir temperatures which are higher than that. And like I said before, it's like a cascade. The more we can push our temperature capabilities, the exponentially more we're going to unlock in terms of power, and therefore improving the potential economics of installations.
Yeah, I guess that goes hand in hand with some of the techniques around temperature management that allow you to drill those higher temperature.
Yeah, they're potentially complementary, because whatever they can get you to, if you have high temperature capability tools as well, they just get you even further.
Yep. Okay. Igor, tell us a little bit about your technology, current status, and maybe some of the biggest challenges you're seeing.
We successfully developed, after thousands to do that. So 2 years ago, we started to work very intensively on the solutions that can be ready now. So move from this future into today. And that pathway was very successful for us this year when we accomplished the test with neighbors, our main partner. It was April, May, when we successfully tested a new technology called Anchorbit. That is the first part of the, let's say, product story. And maybe compare it with some other industries, like supercritical, deep depths, is like some flying to Mars. A lot of things should happen, like a lot of innovations during this pathway. But we first have to fly to orbit, then to moon, to be able to convince the industry and energy partners that yes, this is the viable pathway. So our current approach is, and then I'm heading to this challenge, is that we are now finalizing the new prototype of the first mechanical part of the system that should bring significant rate of penetration increase, lifetime of the whole drill bit, and also eliminating vibrations and stick slips in the drilling. And in practice, it means that it should be ready for the next year to enter the pilot wells. And this is maybe for us the biggest challenge. Always for any new technology startup is funding, as you say, but also for us what is now important to find the best pilot projects and wells. So that's why we also moved from Europe to Houston. So now we became the US company because we see here much more ambitious projects that want to adopt the new things and less risk averse. And hopefully that next year will be for us the key milestone.
Excellent. Perhaps one of your clients, if anyone can hear me, but could be the Army or the Air Force, who seem, you know, very open to some of these challenges, right? That's fascinating. I've looked at plasma drilling and just, you know, research around that. It's been around for many, many years. And it's fantastic to see that, you know, you're working with neighbors and that you think you're a year away from a prototype tool for, so, you know, this Star Wars technology is starting to come to life here. Igor, on that note, you know, and again, playing on the team, there's still a lot of skeptics around geothermal. People have been trying this for a while. Why is it different now? Why do you think this is actually going to work over what others have done in this field, you know, last 30, 40 years?
I believe that what is very important for geothermal, these are two things. First, to show some successful demonstrator, and second, this demonstrator should be scalable. It means that it cannot be something that is only isolated in some special geological environment when you have good conditions, and you cannot bring it to a relevant percentage of the energy mix. And this is something that also we took as a strategy, that first we should show that yes, we can bring the promises that we made. It means to significantly cut the cost of the system, and then to be able to demonstrate it not in an ideal place, but also in the place when it's today not feasible. And that's our strategy for next 5 to 7 years, that we should extend the potential market from today's low percentage regarding the geothermal energy potential, step by step to 10, 20 plus % of the geography when you can make it, and ideally in let's say this 7-10 years to make this potential for the anywhere. Even though we don't think that this geothermal anywhere concept needs to be done like 100%. Even you are reaching like 50-70% of the areas in the future, you are basically covering the needs that could be matched.
John, how about with high temperature tools? You know, the big 3 or 4 have been working on these forever. There's always been challenges around, is there really enough of a market to sort of justify R&D dollars? Why is yours different?
Yeah, ironically, when I was working for Weatherford on the high temperature stuff, I was the one that was questioning the project because, well, how big is the market?
Yep.
And now here I am, you know. I saw the light, right? Jamie helped me with that. Technology development, it moves at a pace, not necessarily because people are brilliant at particular things. If you look at the history of technology development, you'll see that a lot of things were simultaneously invented by lots of different people at the same time. And then there's a scramble to claim, you know, who was the actual inventor. And this goes back hundreds of years. And the reason why that happens is because the sort of technological ecosystem that we work in, it's easy to imagine it as like an onion where you keep peeling back layers. And every time you peel back a layer, there's another layer of technological and scientific discovery that exists there. One example I tell people about is smartphones. And I've got an article that I could show you where smartphones were actually foreseen in the 1950s, but weren't possible until the late 2000s because they required other stuff, battery technology, glass technology, and stuff like that. Not the phone itself, but the stuff around it. And one of the things we hear a lot is, well, we tried that before and it didn't work. And through the whole of my career, I've heard people say, yeah, we tried that before and it didn't work. But the reason it didn't work wasn't because it was a bad idea. It was because the stuff that you needed around it wasn't there. And I can't talk in detail about what that magic stuff is, but you won't be surprised to hear that it involves materials technology, which moves apace on a yearly basis. Manufacturing technologies move apace on a yearly basis. When we do show what the tools we're developing look like, hopefully people are going to go, oh, because they look nothing like the MWD and LWD tools that you're used to. And they're leveraging these materials, manufacturing technologies that have only been available maybe just for a few years.
Yep. I actually think that's true innovation, where you're able to pull things from so many different places and assemble them in a way that haven't been done before to create a new product is really fantastic.
Absolutely, yeah.
Yep. Okay, Silviu, do you want to take a crack at, why is your system different to some of the bits we've seen before in that space?
Sure. So it's different in several ways. So as I mentioned, this heating and cooling market is actually ripe for disruption. So very, very little or no innovation. The skill sets are very limited. For instance, the reservoir simulation expertise from oil and gas, for instance, it's almost none. When we are talking about drilling with air is probably the most common, and then you hit the groundwater level, and then you are wondering why things are not going well. So a lot of details that for oil and gas people, are very trivial. But in terms of challenges for this industry, I think right now the biggest challenge is the business model. So as I said, the market is very fragmented. There are very small, individual companies doing even drilling or project management or engineering, very, very little integration. And so because of that, what happens is that over time, most of the geothermal heating and cooling systems installed, at least in the United States, have payback periods of, very variable between, I would say, 8 years and 25 years, depending on the size of the building. And so no serious, financial institution will back up such a system, right? So it's a narrative that needs to be destroyed, and Bedrock is addressing exactly that. We are trying to figure out how to provide a system that is financeable. So when we come to a building owner, they will know exactly how much will cost them and how long it will take them to pay that off. It's not really about technology. They are not interested in that. They just want a system that delivers whatever thermal requirements they have. But what matters to most of the large buildings owners that we are addressing and we are interacting with is that certainty about their finance. So we are addressing that, and probably nobody in the industry is addressing right now.
Okay, so innovating on the business model.
Yes.
Okay. All right, I think we have time, Taylor, for maybe one question from the audience before we wrap up. Anyone with a question for these folks on their technology innovations?
Y'all better come up with one question. Oh, now we got way more than one question.
So this is my first pivot meeting, and I'm a geologist, and I work in the oil and gas business. And it seems that you're adopting the oil and gas technology. I mean, are you actively hiring people from the oil and gas sector to work with you, or you just read their papers, or what's your connection with that?
I can start if you like.
Yeah, sure, please.
So yeah, my background was like 35 years in the oil and gas industry. So the kind of the structure, and Steve, my co-founder, the same, possibly even longer. I think he's even older than I am. So the structure of the tools and their function is very, very similar to what we used to, and we're leveraging that because we're still drilling wells, and we can take all the knowledge we've got about drilling wells, but we're trying to do it at higher temperatures. And so we broke our engineering team into two. We've got one team looking at how to make the electronics work as high as possible. And that team is based in Houston because, as you say, we can leverage the ecosystem that exists here. There are engineers, manufacturers, vendors, chip suppliers who can give us a lot of the stuff we need. But the other side of it is about materials technology and thermomechanical engineering, managing the heat. so that each of the components we've got is in the temperature which suits that particular component, which becomes quite a complex problem. And we've decided to do that in Spain for a number of reasons. But one of the reasons is there's a very well-educated workforce there who are very good engineers. And these guys don't know that what they're doing is impossible. And when you give people stuff and they don't know it's impossible, they actually manage to make it work. So the stuff which is not familiar to the oil and gas industry, we're using people who aren't from the industry. And the stuff which is more familiar to the industry, we're leveraging it and we're using people who are from the industry. So it's a kind of hybrid approach.
Is he answering your question? Yes.
Good, okay.
Maybe just to add one point to that, what is important that for us, it was a good combination of the people in a team from the industry and out of the industry. More on the R&D side, I mean research, to have a really good electrical engineers, scientists, mechanical engineers that are able to push the borders or let's say potential limits, and then to be corrected or let's say managed by the people with experience that can say this will absolutely not work, and that could maybe work. And that I think was the core of success when we reached the point where we are today, that we were able to connect these two worlds.
Good. Silviu, do you want to wrap us up with a final comment on that question?
Yeah, one minute. So yes, for us, actually, I would say about 66% of the company currently come from oil and gas, but that's just a coincidence. What we are looking especially are problem solvers. And personally, I'm evaluating somebody who knows how to solve problems, throwing at them more than the oil and gas expertise. It just happened that, most of the people in our company come from oil and gas just because, they are problem solvers. But we are not looking especially for oil and gas people.
So you see, the pivot is real. It's happening. All right. I think we're out of time. I'd like to thank our panel, John, Silviu, and Igor, for a really good discussion here. And thank you all.